Today we are doing 2.2, which is graphs of functions. So by the end of today, you're going to be able to analyze and graph piecewise functions and select appropriate viewing windows on a graphing calculator. You are going to find that, yes, you have done these before, but judging by some of our preview worksheets, we do need a review of the piecewise functions, and that is exactly what we are going to get today. Okay, so those are our two objectives, and if you would like to put those on your homework log, you can absolutely do that. And once you've written that down, go ahead and read through example 1. Okay, so Nick, what is example 1, Nick D, what is example 1 asking us to do?
Which window shows the graph best?
Okay, so we have to choose which window is going to show the graph best. And I have to choose what lighting is going to show my calculator best. Ooh. Okay, let's see. All right, so hopefully we do remember how to graph. So we're going to go to y equals, and we're going to have x to the 4th. Here's your variable button. Are you guys super excited? You get to use your calculators today?
So excited.
Thank you. Okay, and then what we're going to do is we're going to graph that in the 4 different windows that are given. So to adjust the window, you are going to go to the window button, and then you have your x min and your x max, which is negative 10 to 10. This scale means that's what your tick marks are going by. So you're going up by 1s, and then negative 10 to 10, and then we're just going to hit graph. Then whatever you see, I want you to write that down. Okay, you can see my graph is done. Does your graph look like mine?
Yeah.
Yeah, can we see anything? Nope, so for that one, for A, we're just going to write no graph. Okay, so if you were doing that on your homework, you would just write A, no graph. Okay, that way you can see that you actually did it. So let's go to the next one. You have negative 5 to 5 for your x's, and then your y's are 0 to 15. So whenever you're given these, you'll always be given the x scale first. So this is your x scale, and this is your y scale. Okay, and then so my y is 0 to 15. I'm just going to keep it to go by 1s. I'm going to hit graph. Okay, so again, I have no graph, right? Okay, so that was what my window looked like, right? I just had a 10 by 10 coordinate plane on the first one. On this one, I have 0 to 15. Okay, so I have no graph. All right, let's see what happens with C. So I'm going to go negative 2 to 2, and then 18 to 28. Okay, so yeah, I actually have a graph. I'm just going to draw a rough sketch of that. And then I'm going to go ahead and see what part D gives me. Okay, so for part D, I have negative 2 to 2, and then negative 100 to 100. Okay, so negative 100 to 100. So here, it kind of just looks like we have a little bit of a curve, and then it levels out, and then it curves again. Okay, so which choice would you say is the best one?
C.
C. Okay, C is the best choice because it gives you the entire shape of your graph. Okay, so select the one that produces the most appropriate graph of the function, and so C is going to give you the most appropriate graph. Okay, so that's what you would select. Okay, questions for me on example 1? All right, let's go to example 2. So for example 2, we are going to start sketching the graph of piecewise functions. So for the piecewise function, you are given two different pieces. You have 1 if x is less than or equal to 1, x plus 1 if x is greater than 1. I wrote out the steps here for you. So step 1, it says identify the type of function, and then also what will the graph look like. Okay, so the first one is 1. Remember, that's the same thing as just y equals 1. What would we call that type of function? Can you tell me? Y equals 1 is what? What do you guys think? Why are you scared to tell me something? What is 1? The constant term, right? Okay, so that's just a graph of a constant. And if it's y equals 1, when you're looking at the graph, we talked about this yesterday. What does that look like on the graph? A horizontal line. Remember we talked about that yesterday? You remember it vividly, apparently? Okay, and then what about the second one? So I have x plus 1, so it's like y equals x plus 1. Okay, Jackson, what kind of function is that? If y equals x plus 1. So what type? Okay, okay, Eddie, what do you think? It's linear, right? How do you know? You know because of, say it again? Yeah, the degree of x is 1, right? Okay, if it had a power of 2, what would we call that? Quadratic. Okay, it is not linear, so but we are going to call it quadratic. And then if it's to the third, it will be cubic. And then do you remember the fourth? Quartic. Okay, good. All right, so another thing I like to do is write what the graphs will look like. So this is linear. If it's linear, it can either go up from left to right or down from left to right. What tells you whether it's going up or down? The slope, okay? And then, Yusuf, is this going to be going up or down? Up, because the slope is what? Yeah, the slope is 1, right? Because of this one, not that one. All right, so now I know what my two pieces of the graph are going to look like. Step 2, you're going to make a table. And then it says include points in each interval and mark as an open or closed circle. So you have to include the points in each interval, and we're going to mark as open or closed. And I'm going to walk you through this first one, but I also want you to be thinking. So because I have two equations, I'm going to make two tables. One of my tables is going to be for f of x equals 1, or y equals 1. The other one's going to be for f of x equals x plus 1. Okay, so for my first equation, it says if x is less than or equal to 1. So whatever is included in this interval has to go on my chart. So I'm going to put a little star by it. That is going to be a key point, a key value. Now if I plug in 1, what is my output going to be for this? 1. And now I'm just going to pick some other ones on the interval. Now, because this is less than or equal to, what type of circle am I going to have? Yep, so I'm going to do this, or I can just write closed circle. And you only have to do the open or closed circles with your key values. Okay, so 1 is a key value. Now I can just pick any other points that are in the interval. So it says x is less than or equal to 1. What would be another x value that's in that interval? If it's less than or equal to 1? 0, okay, what else? -1, okay, so if I plugged in 0, what would my output be? 1. If I plugged in -1, my output would be 1. Okay, so really, I know this is going to be a straight line. Let's go ahead and let's graph that one piece, okay? So I'm going to start with 1, 1, which is a closed circle. So I'm going to go to my graph, and at 1, 1, I'm going to put a closed circle. Now, remember, I said these points here, these are not key values. So you don't have to put open or closed circles. Those are just going to be points. So I might just put a little dot there for 0, 1, and then a little dot for 0, negative 1. But what's going to keep happening as I go to negative infinity with a constant? It's going to stay the same, right? Okay, so you just have to span your whole graph. So in order to span my whole graph, I just need to make that horizontal line going to the right. Or sorry, going to the left, not to the right. So if this was just y equals 1, the whole entire line would be part of the graph. Because we're only looking at it from 1 and less than 1, this is our 1, 2, 3, 4, 5. Okay, we're only going to graph that from 1 and then all the numbers below. So from 1 to negative infinity. Okay, is that first piece okay? Do you have questions for me about that? Okay, let's do the second piece now. So again, I have to look here to find what my key value is. What is my key value? It says it's greater than 1. So your key value is whatever you see there. So if you have this 1 here, your key value is going to have to be 1. Okay, so you have to include 1 on your table. And I'm going to put a little star because that's our key value. Now for 1, is that going to be an open circle or a closed circle? Open. So this is going to be an open circle. And let's talk about what some of you may be questioning. So we are going to plug in 1 into this equation, right? 1 plus 1 is going to be 2. Now, some of us might think, well, how can I plug in 1 if it doesn't include 1, right? If you just started with 2, which is a number that's greater than 1, do you guys know what values you'd be missing? Why you couldn't do that?
The numbers between.
Yeah, you'd be missing all the points between 1 and 2. Okay, and remember there's an infinite amount of points in between there. So you have to include it with the open circle, because then it's not going to include 1, but it will include all the decimals in between those two. Okay, so I could also do 2. So if I plug in 2, 2 plus 1 is going to be 3. And I could plug in 3. 3 plus 1 is going to be 4. So now when I graph this, I can go ahead and I can just graph my points. So at 1, 2, I have an open circle. And then the other 2 are just points. So I have 2, 1, 2, 3. So that's just a point, 3, and then 4. Now, I've been using the table, but if you wanted to, could you find what those points are using a different method? Yeah, you could use what? You could use the slope, right? If the slope is 1, you just go up 1 over 1, up 1 over 1, up 1 over 1. Okay, and then you have a line here. Now, once you graph these, I'm hoping that you can see that those 2 lines, are they overlapping? No, they should never overlap. Okay, so with some of you, if you got your sheet back today and I like circled on your graphs on your piecewise function, it's because you were crisscrossing them. Okay, there's no way that can happen because they're on different intervals. You can have one point that overlaps, but the lines themselves are never going to overlap. Okay, so we're just going to make a little note of that. So note, and piecewise functions. The lines will never overlap. Okay, and then again, remember I said a point can overlap. The lines are never going to overlap. Okay, so sometimes they will meet at the same point. So we'll actually talk about that in the next one. All right, so then let's flip it over. All right, so for part B, you have 3 different equations. Real quick, I want you to go ahead and label what those are named, and then see if you can draw just a little sketch next to it. Okay, so Aiden, for number 1, what type of function is that?
Linear.
It is linear. Is it going to be going up or down from left to right?
Up.
Yes, good, okay, because you have a positive slope. All right, and then Kaden, what about the second one?
Quadratic.
Okay, and with a quadratic, do you guys remember what the graph is called? A parabola. And with a parabola, it can either open up or open down. Nick S., is this opening up or down, and tell me why?
Opening down.
Yeah, but do you know why?
Negative x.
Okay, yeah, so if there's a negative in front of the x squared, then the parabola is going to open down. If it's a positive in front of the x squared, then it will open up. Okay, and then Logan, the last one is what type of function?
Linear.
And then is that going to be going up or down from left to right?
Down.
Good, and that's because you have the negative in front of your x. Okay, so I have 3 different functions. How many tables should I make? 3. Okay, and remember you have to put your key values on there. So let's actually go through, let's do our key values first. Okay? Colin, what's our key value for the first one of f of x equals x plus 4?
0.
Yep, so 0 is our key value. Is that going to be an open circle or a closed one, Colin?
Close.
Closed, good. Okay, so I'm just going to put this, I'm going to put closed. Okay, Michaela, for the second one, what is our key value or values?
0 and 2.
Good, okay, so 0 and 2. And then Yusuf, is 0 going to be open or closed?
It'll be open.
Okay, what about 2?
That's close.
Yep, good. All right, and then Dylan, for the last one, what's our key value?
0.
Tell me why you're thinking that.
Oh, 2.
Okay, can you tell me how you know?
Because all the points from 2 to 3 are in the thing, but not 2 itself, so it'd be open.
Okay, yeah, so you have 2 is less than x, right? So this 2 is telling you that that's your key value, and then it is going to be an open circle because there's no equal to. All right, so now let's go ahead and find the y's or the outputs to those values, and also find some other ones that are on the line. So if I plug in 0, 0 plus 4 is 4. This is x is a less than or equal to 0. So Liam, give me a couple of other x values I can use. Good, okay, so -1, -2, when you plug them in, -1 plus 4 is 3, -2 plus 4 is 2, perfect. If this is 0 and 2, I'm probably just going to put my 1 in between there. If I plug in 0, 4 minus 0 is 4, 4 minus 1 squared is 3, 4 minus 2 squared is going to be 0. Okay, and then Anna, for my last one, what are some other values I could put on here?
3 and 4.
Okay, and Anna, when you plug in 2, what do you get out?
2.
Yep. And then -3 plus 4 will be 1, and then -4 plus 4 will be 0. Okay, so now we're going to go ahead and graph those. So you guys can give it a try. Okay, and then I'm going to start with 0, 4. So 0, 1, 2, 3, 4.
Still like, they started this.
Okay, so that's a closed circle. And then I have negative 1, 3. So negative 1, 1, 2, 3. And then negative 2, 2. Okay, so if I connect those points together, I'm going to do that with a straight edge. I want to just double check with what I already told myself, that this is linear and going up from left to right. Is this going up from left to right? Yeah, okay, if you're going up the roller coaster, yep, that's what's happening. Okay, for the second one, I have 0, 4. Well, I already have a closed circle at 0, 4. It says now I need an open circle there. Does anybody know what you have to do for that?
Let's circle around the other one.
Nope. But that is a common thing. So I say no targets, right? So you don't want a closed circle with an open circle around it, no targets. What you are going to do is just leave it closed. So if, we'll write a little note, if you have an open circle and closed circle at the same point, you will leave it closed. Okay, if you have an open circle and a closed circle at the same point, you will leave it closed. So we already happen to have it closed first. If it was open first, you would fill it in. Okay, and that would be fine. So for 0, 4, I don't have to replot that. I can leave it. And then I have 1, 3. And then I have 2, 0. Now, 2, 0 is going to be closed, so I am just going to make that a little bigger. Now, when you're connecting your points, again, keep in mind what the graph is going to look like. So this is a quadratic, so it's going to be a parabola. So when I'm connecting those points, I have to do so with a curve. So it's not going to be a straight line. It's just going to be a curve as you're going down. Okay, so you should have a little bit of a curve to that one. Then for the last one, at 2, 2, I have an open circle. And then I have 3, 1, and then 4, 0. And so again, once I graph this, I can check. I said that this would have to be going down from left to right. And is it going down from left to right? Yep, it's going down the roller coaster, right? So then that will be my graph. So again, the reason why this is curved is because it is a part of a parabola. These two are linear, which is why you have a straight line. Okay, questions for me on that? All right, I want you to read the directions for example 3. Okay, so you're given a family of functions. This is the equation that you're given. We are going to graph all members of the family in the viewing rectangle. So we're going to graph it, and then we're going to draw a rough sketch. And then in part C, what we're going to do is state the conclusion. So let's go ahead and do that. If you plug in 0 0 for C, x minus 0 is just what? X. So it would just be x squared, right? So that's going to be one of the ones that we're graphing. For the next one, we would be graphing x minus 1 squared, and then we'd have x minus 2 squared, and then we'd have x minus 3 squared. Now, some of you probably already know what's going to happen from your Algebra 2 days, correct? You guys think that you already know? Did we all become mute today? What do you guys think? What do you guys think is going to happen? It's going to get bigger, smaller, it's going to rotate, reflect, shift.
Transfer over.
It's going to translate. Do you guys know if it's going to translate left or right?
Right.
Oh, so you do know.
Axis, I don't know calculator.
Okay, so if you look at the way that it's graphing, the bigger the C value, the more it shifts to what? The right side. Okay, so we're just going to draw a quick sketch of that. Okay, so I had x squared. And then if you guys want to use different colors, you can. Some of your graphing calculators now actually do the different colors for you so you can see them, and it's actually really nice. Okay, so then you have a nice little sketch of what that looks like. Now, for the second one, what do you think is going to happen when you plug in the negatives? Yeah, it's going to shift the other way, right? Okay, so for these, I would have x squared. What happens when you do minus a negative? Turns into plus. So then for part B, I still have my x squared, but then it shifted to the left. Right, so then for C, you have to say, how does the value of C affect the graph? And when you're writing this, be specific. So we're going to talk about part A first. So in part A, the graph shifts to the right. As C becomes larger, the graph shifts further right. Okay, so as the C value goes up, the more it's going to shift to the right. In part B, the graph shifts left and shifts further left. As the C value. What is the C value doing for part B? Getting larger or smaller?
Small.
Getting smaller. So as the C value decreases. Okay, so in part B, the graph shifts left and shifts further left as the C value decreases. All right, and then I'm going to give you a minute to read through example 4. Go ahead and highlight or underline anything that you think is important. There's a lot of information in there.
Oh, these. I thought it meant in equation. I think it's the same thing. Yeah.
Good. Some of you guys have already even started writing your piecewise. So you have the postage rate. If it weighs 3.5 ounces or less, it's going to be 44 cents. And that is for the first ounce. And then it's an additional 17 cents for each additional ounce or part of an ounce. Express the postage P as a piecewise defined function. So that's what it's asking us to do. Express P as a piecewise defined function of the weight X of a letter with, and this is what I'm going to give to you, with 0 is less than X, which is less than or equal to 3.5. Okay, so I'm giving you that part. And you are going to sketch the graph of that function. All right, so we're going to do this part together. So first of all, it's P, and then X is the weight. So normally, when we were doing our piecewise functions today, they were f of x. This is going to be what? P of x. Okay, so P of x is going to equal, we're actually going to have a big piecewise function here. So we'll talk about that. Okay, so the first thing it says is that it's going to be 44 cents for the first ounce or less. Okay, so 44 cents for the first ounce or less. So the 44 cents is going to be the postage that you pay if the weight is 1 ounce or less. So think about that. If you have an item, what's the lowest weight that you can have? Really, it's going to be 0. So if it's anywhere between 0 and 1, then that's going to be your first interval. Now, if you do have something, it's gonna weigh more than 0, so that's why we don't wanna include 0. Then there's going to be the next step. So it says it's 44 cents for the first ounce, plus 17 cents for each additional ounce, or part of an ounce. So the next part of this function is gonna be from 1 up until what? Up until 2. Okay, so the first part, it says letters weighing 3.5 ounces or less. That's going to be part of our entire interval. So see how it's 0 is less than x, which is less than or equal to 3.5? Right here, you have your 0 is less than x, which is less than or equal to 3.5. Could you guys figure out how much it would cost if it was greater than 1 ounce up to 2 ounces? So it's 44 cents plus how much for an additional ounce? 17 cents. So if we take 44 cents and add 17, that's going to give us how much? 61. Okay, so it'll be 61 cents if the ounces are between 1 and 2. I want you to see if you can figure out the next interval. So each time you go up an ounce, how much is it increasing by? How much more does it cost you for each additional ounce? 17 cents. So how am I going to find the next value? I'm going to add 17 cents, right? Okay, so if I add 17 cents to 61, what am I going to get? Okay, so it's 78 cents if the package weighs between 2 and 3 ounces. Okay, so you can't have this both be included. If it's 2 ounces, it is going to be 61. But if it's greater than 2, that's when it'll be 78. Okay, do we have to go up more? What's the final value we have to go up to for this? Yeah, 3.5. So because this is our domain, our next interval is going to be from 3 up until 3.5. And again, that's because of this interval. So this says, with x being between 0 and 3.5, so my first number is 0, my last number is 3.5. Okay, can you guys see how this inequality is relating to our intervals on the piecewise function? Okay, and then let's go ahead and find out the last one. So to find out the last one, I just have to do what? Add 17 cents, right, to 78. Okay, so what is that going to be? Yep, 95 cents. Okay, so now what I'm going to do is I'm going to graph it. This is actually a special type of function. It is called a step function, and it is a piecewise. It is a special type of piecewise. Okay, so we're going to go ahead and graph this, and I'm going to label my graph. So on the bottom, that is my x value. This is going to be my p of x. And the x value represents the what? What does x represent?
The weight.
The weight, okay? So it's going to be the weight, and that's measured in ounces. Okay, so I'm going to go 1, 2, 3, and 4. That's all I need to go up to. Okay, the p of x is representing the what? Yeah, the cost, right? Okay, the price in dollars, the price of your postage. Okay, so what's the highest number I'd have to go up to? I have to go up to $1, right? So what would be a good scale to go by? That, okay, yeah, we could go by 20-cent intervals. So 20 cents, 40 cents, 60 cents, 80 cents, $1. All right, and then let's go ahead and plot our points. So the first one is 44 cents between 0 and 1. So this is 40. Halfway in between is 50, so I'm going to estimate to where that's going to be. And that's going to go to 1. So I have an open circle at 0. At 1, I have a closed circle. And all of those are constants, correct? So if they're constants, I should have a horizontal line. Sorry, I'm just going to zoom in so you can see it. Okay, let's do the next interval. So the next interval starts at 1, and it would be 61 cents. So it's going to be really close here. And then it would go to 2. And then I'm going to do the next one. So at 2, it's an open circle. It's 78 cents. So if this is 80, this is going to be a little bit below 80. And then 3 will be a closed circle. And then my last one is 95 cents. So I'd say halfway between 90. So about halfway between there will be 95. Oops, and I want to put it to the halfway mark. So I don't want to go to 4 for this one. I want to go to 3 1/2. Okay, so that last one should look half as long as your other ones. And now, can you see why they call it a step function? Because what do they look like? They look like stairs, right? Choo, 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 choo. Maybe some Mario stairs there. Okay, so because you had a lot of graphing on your homework, you need to put your homework on graph paper. If you need graph paper, I will give that to you.